I would like you to do an investigation here into how each of these digital logic gates work and complete the following truth tables. So the truth table tells you what output you will get for the given inputs possible. So just go ahead and click right here on Circuit Verse, and this will open up. And this is a simulator for digital electronic logic. And the first one I want to do is this one here. So I'm going to copy this out. So the gate looks like this. And then we have A and B, that's the two inputs, and then we have the output. So on a sheet of paper that you're going to hand in, or if you want to do this on your computer and then submit it. And if you look closely here, the pattern is 0, 0, 0, 1, 1, 0, 1, 1. And those numbers indicate when the inputs are off if it's a 0 or on if it's a 1. Okay, so now we're going to have a look here. And we've got to have two inputs, so I'm going to drag them out from here. See how they're at 0, 0. I need a gate, and I want a gate that looks just like this one, and that is here. And see how this gives me the name of it? It's called an OR gate. So I'm going to put that in my note. So once you find the names of these, you put them in. This is an OR gate. So I'm going to drag that OR gate out here. And then to figure out what's happening with it, I need an output. And I'm going to go ahead and connect them. So I'm going to connect the output and connect the inputs. So that red line means it missed. Let me try that again. So I'm just left clicking on the dot to make the connection. Left click and then drag your mouse over, it'll draw a wire for you. Okay, so now with both of those off, the output is off. So if they're both off, the output is off with an OR gate. If the first one is off and the second one is on, the output is on. If the first one is on and the second one is off, the output is on. So we call this a truth table. The truth table shows all possible combinations of inputs and lets you know which output will go along with that. And finally, if both of the inputs are on, the output is going to be on. Okay, so if you look here, identify these logic gates by name and complete their respective truth tables. So for the first of these 9, I've done this here. I found the name's an OR gate, and by simulating the inputs and looking at the output, I've completed the truth table. I want you to do this for the other 8 of these here, and that one as well. And you're going to get that on a sheet of paper and then hand that in. So if you click over here and then under where your name is, there's a spot for assignments, and then you're going to hand this in. One thing I want you to notice is, see how here you have these little circles before the inputs? They're not available to you here, but what they are is inverters. So if you just go, see how there's a circle there? That's an inverter at the output, but we don't have an inverter at the input. So to do this third one here, where you have inverted inputs, I'm going to ask you to take the gate, and then this here is an inverter, so use that. So I am inverting the inputs. So what I've done here, I put inverters before the inputs, and I'm using that for this one here, where the inputs are inverted. Other than that, you are going to find everything that you need here, right along here under gates. So go to input, get a couple of inputs, go to gates, get the appropriate gate, or make the appropriate gate if you require inverters at the inputs. And then go to output, and we'll just use that output here. Find the names and complete each of these truth tables and then hand them in. Now, we don't really have a name for this. It is the same name as that and then right with inverted inputs.